Hi everyone, and welcome to the second Women on Stage conference. Thank you for being here with us again. I'm still super excited to be here, and I'm thrilled to have all of you joining us once again. My name is Moran Weber, and I'm the CEO and founder of Women on Stage. And for those of you who are only joining us today for the first time, Women on Stage is a global community platform to showcase, book, and train women professional tech speakers for any event, conference, meetup, or webinar. The platform was launched in May 2020 and achieved overnight viral success, already making it one of the largest databases in the world for women professional tech speakers. Our mission statement is to create a world where women make at least 50% of tech speakers and to amplify their voices, because we believe that if you can see it, you can be it. And apart from the platform, we also launched the second course of the Women on Stage Academy, which is a full-blown course to train the next generation of technical women on stages. And today is the third and last day of our ending conference, where each of our 30 graduates will present their talks after they've been building and polishing and working on their presentations throughout the course for the past 3 months, after getting personal tailored feedback from world-class speakers and mentors. Our speakers are working in senior positions at some of the best-known tech companies in the world. And on top of that, we also have 3 engaging keynote speakers opening each day. Our speakers are going to present highly technical professional sessions covering data, machine learning, NLP, backend, cloud and big data, frontend, React, mobile native development, security, software engineering methodologies, quality assurance, architecture, and many, many more. And before we start, I'd like to thank again to all of our people and the companies who made this course and this conference possible. Thanks to all of our awesome sponsors who actively choose to promote diversity as part of their mission. We truly couldn't have done this without you. Be sure to check our job board with wonderful job opportunities from our sponsors. Thanks to Event Handler Productions for producing the conference and to the team organizing the event. Special thanks to all of the course instructors, which are world-class speakers and true legends. And last but not least, to our talented, brilliant, and dedicated mentors who accompanied the students throughout the course. Alright, so one last thing before we start, you're welcome to ask questions on our YouTube channel. The sessions are pre-recorded, so the speakers are going to be available during their talks to answer all of your questions live. We love to hear your thoughts. Ready? So here we go.
Hi everyone, very excited to be here today. I'm Shani Merdler, I'm the VP Product of Minute Media, and today I'm going to speak with you about leading your way forward. So before I'm getting into who I am, the entire story, I'm going to start as a product person with why. Why are you here? Why are you listening to this talk? And my assumption is that you probably read the description and you're in this stage in your life where you're at and where you want to be, there is a gap between the two. And this is exactly what I want to speak about today. I want to speak with you about how to get to where you want to be. So after we cover the why, I'm going to speak now about, I'm going to present myself, talk about where everything started, and then show you what's the approach that has helped me to become who I am today and where I'm at today, and share with you some tips and examples from my way, all of that in a second. So first of all, I'll start with where everything began. And this began in Minute Media. For those of you who are not familiar with Minute Media is just the most promising startup by Calcalist. We are a tech platform for storytellers. Our mission is to power the most passionate storytellers out there. And if you're looking at the stats, you can see that we powered over 350 million unique users a month. We have 6 offices, 6 brands, and support 13 languages. So now a bit about me. When did I start working for Minute Media? That was a really long time ago. In 2013, 8 years ago, I joined Minute Media when it was very small, only 20 employees. And I joined as a QA engineer, just got released from the army. And like many Israelis do, get released from the army, go to work for 1 year, save money, and then travel. I had the same thought in mind when I joined the company. Thought this is going to be a very short ride. I'll join for 1 year and then I'll say thank you very much and continue to my trip. And as you can see here, that's not exactly what happened. And my path with Minute Media still continues today. So what happened there? So after 1 year, I had a conversation with the CEO that probably sensed that I'm very young and I'm probably going to say goodbye soon. And he asked me whether I want to lead the QA team. I told him that I'm not very interested in leading the QA team, and he asked what am I interested in. So I shared with him that actually what seems more interesting to me is to become a product manager. And he asked, what's my plan for that? So I said, very simple, I'll go and study computer science, then I'll work as a software engineer for a few years, and then after a few years I'll move to product management. And then he said, you know what, I believe that if you want to do something, you need to do it now. This is an advice that I'm taking with me until today. I'm sharing it with everyone that I come across with, and gave me the opportunity to become a product manager and join the product team. So from this point on, I'm going to speak about, how everything is about what you're doing, how you need to take responsibility over the path of your career. But at this point, I just want to say that sometimes you just need luck. You need to be in the right place with the right people to get the opportunity that will enable you to move forward. So now after we spoke about this point of time, I'm going to speak about the rest of my journey, the challenges that I've encountered, and what's the approach that helped me go through all of that and become the VP product of the company. So in order to understand it, I think that you need to understand what's my position in life at that moment. I'm 21 years old, working at a male-dominant environment, very young relative to my peers, and I want to take a very leading position as product manager and lead the product of the company at that time. Now, what's happening is that I'm feeling quite insecure, but I know how good I am and how good I want to be. And at that time, a really good friend of mine bought me this book. And this book is, as you can see by the title, it's not how good you are, it's how good you want to be. And that's something that really helped me and still helping me to navigate my career path. And when you open the book, these are the first few pages. Nearly all rich and powerful people are not notably talented, educated, charming, or good-looking. They become rich and powerful by wanting to be rich and powerful. Your vision of where or who you want to be is the greatest asset you have. But without having a goal, it's difficult to score. So that's the first point of where we are. It's not about where you are at now, it's about where you want to be and how good you want to be. That's our starting point. And without having a vision of where you want to be, everything that I'm going to say in this presentation is irrelevant, because I'm going to help you direct your way to where you want to be, and if you don't know where it is, then this is the first step that you need to take next. Now, let's say you're now in my position as a QA engineer back then, and you want to become a product manager. Not only a product manager, you want to become a good product manager. Now, what's next? There is this quote that I really like, which says, "The journey of 1,000 miles begins with a single step." So here in the picture, you can see me doing a handstand in Cuba. And basically what led to this picture is many unsuccessful tries and attempts before that. Now, when someone wants to stand on their hands, the first thing that they want to do, the first step in the way, is to try and kick against the wall, because what you need to make sure is that your legs and your hips are above your head. This is the first step in this journey. And it doesn't really matter where you are at this moment. You need to think, I want to become X. Now, what's the first step that I need to take in order to get that? That's the first advice that I have for you. Now, when you're thinking about what's the next step, what's the first step for me, it's really important to remember the following thing, because you could make a mistake even on this first step. Now, your assumptions are your windows on the words. Scrub them off every once in a while, or the light won't come in. And this is a very important quote at this moment, because, for example, if you're seeing and taking an example of my journey, I thought that the first step that I need to do and take in order to become a product manager is to go and study software engineering for 4 years, then become a software engineer and continue in my path. It's very important to test your assumptions before you're going and pursuing them in order to make sure that you're in the right direction. Now, after we're choosing our goal, deciding our first step, then what? Now, I'm a product person. We started with why at the beginning of the presentation, and the approach that I really like to take to career path is to think that you're the product. Many times, when we're thinking about this ourselves, we can become very sensitive, very emotional. Unlike when we're, for example, giving advice to a good friend. It's very easy to detach yourself from the feelings when you're giving advice to someone else, but when you're thinking about yourself, sometimes that can be harder. So I encourage you to think about yourself as the product. You're the product. Now, when we're thinking of a good product and we're planning the product roadmap, what are we thinking about? So the first thing that we've already spoken about is a clear goal, where you want to be. The next thing is creating a roadmap. You have the first step, but after the first step, there are many different steps. What can you do in order to create your roadmap? You can look at where you are today and where you want to be, and then assess what needs to happen in order for you to get where you want to be. Plan this roadmap very similarly to how we're planning roadmaps for products, and then you already have the second step in the way. Now, sometimes when we're looking at this way of like where we are now and where we want to be, it can be very discouraging, because it seems like it's a very far target from us. It's going to be a very long way. We will never get there. We maybe better not even try. Now, what really helps, at the beginning we can be very motivated, be like, yeah, we're going for there. And then once we start the way, there are many barriers, obstacles, and we're getting really tired on the way. Maybe people frustrate us, and that takes our energy away from us. So what can we do in order to prevent that? What we can do is set key milestones in the way. Look at the roadmap and say, I'm stopping here and here and here and here in order to celebrate and say, well done, right? I've done all this way. I'm already hitting my first key milestone, my second key milestone. That will re-energize you and just show you not only what's the way that you have ahead of you, but also what's the way that you've already gone and how much progress you've made, and make you believe in yourself that you can also hit the next target, the next key milestone that you have on your list. Another thing that is really helpful, like any product and any good company, is having an advisory board, right? People that already have the experience and knowledge in order to help you shape the way and make the right decisions in the way in order to get where you want to be. This is something that really helped me during my career path. Along the way, I had many different mentors from different programs, and something that is really important to remember is that the advisory board could be of people that you never thought of. I can say that one of the tech leads that I worked with is one of the people that I learned the most out of. And he's, as I see it, even if he didn't know, part of my advisory board. Now, where can you find advisors, right? So there are many different mentorship programs according to professions, women mentorship programs, and so on. But it's really important to remember that also within your organization, you can find really good advisors. Probably that the people that are more senior than you have seen and done many things before that you're not even aware of. So a recommendation from my side is to identify these people and really ask for their knowledge, ask for them to help you in the way, even if it's not a very, it's not a full-time mentorship program, even if it's only consulting on different topics, this is something that can really help you. What you also need to consider when you're taking someone like that is within the organization, is senior than you, is that along the way, when you want someone to vouch for you, he will already be there, he will already know you, he already know your capabilities. So it's basically a win-win situation for everyone. So that's on the advisory board. And basically, I think that most of you now think, how am I going to get the advisory board? How am I going to get the mentor? Maybe you already Google now mentorship programs for women, for different professions. But before I'm getting into all of that, I want to speak about something that is really important. Like any product, people will not know how good you are unless you show them. Now, if we're looking at the peacock as a product, one of his features it's his beautiful feathers. Now, if he wouldn't show it to us, we would not know that he has these amazing feathers, right? So very similarly, also you're the product, you're improving over time, but if you will not show it to people, it can create a lot of frustration on your side, thinking, how can they not see how good I am? How they did not see how good of a job I did, how I spoke in this last meeting. So, same as you have your own path, also other people have their own path, and sometimes people just don't see. Yeah, that's what happens. They don't ignore you, it's not on purpose, they just don't see, and you need to show them how good you are. It's on you. Now, going forward, how are we making people, follow us? How can we lead people going forward? What are the next steps for us? So a couple of tips from my side after reading many books on this topic. Really interesting. If you're interested, you can follow me, and I will reach out to me, and I will send it to you. Now, everything is around influence and lead. What's the first thing? Sense of importance, right? So each one of us, it doesn't really matter how senior we are in our positions, we want to feel important. People really appreciate that when other people see them, that gives them the sense of importance. So when you are reaching to someone to ask them to be your mentor or advise you, or if you want to convince someone of a certain path that needs to be taken, a new product that needs to be developed, or a new initiative that you want to run, think about the sense of importance. You need to make sure that you see the other person, you show them that you appreciate them, and that will do a lot of the work, I can assure you. So it's not only about you and your idea, it's about the other side, how you see the strength of the other side, and help him help you in the way that you want to take. That's the first thing. The second thing that I want to speak about is look through different lenses, right? So Similarly to you have a roadmap, you have a goal, you want to be in a certain place. Also, this other person has his own goal, his own roadmap, and now you want to take this person on another path, perhaps, than the path that he imagined. Now you need to be able to look through his lenses and think, what does this person is interested in, right? What's the path that this person wants to go through? What he's interested in. Now, once you see that, the message that you need to convey to this person is not how much you need him to help you or why your way is the right way, right? Imagine now I'll come to you and I'll say, my dream in life is to be the VP product of Minute Media. Can you please help me? I really need you to teach me that and that and that. Now, you have another goal and your time is precious. If I will not show you how helping me also helps you, it will be much harder for me to convince you unless you're super, super kind and you're willing to give away your time. It's going to be very challenging for me. But if I'll come and say, I want to learn this topic and I know that you want to become better at teaching it because I saw that you're very interested in this topic. You're going to build a course on that. What do you think? Maybe I can be the first one that you're testing your new course on. Then this already sounds very different. What did I do? I looked at the person, identified what is important for him, and I tried to find a way, a path where both of our paths cross and come together in order for us to collaborate. The next thing that I want to speak about is positive messages. Now, sometimes we think that we see it all, maybe we are right in our way, but the way that we convey the message is not positive. It makes it hard for people to listen to us. Now, at this point, basically what we're doing is we are right. We're coming into it could be a meeting about how should we solve a specific problem or any other topic, and we are right. We know that we are right, and we're going to speak now and tell everyone how bad this is going to get if they won't listen to us and if they won't take our solution. Now, that's a point where we're already losing. Why? Because I learned from studies that people are less encouraged to listen when other people convey their messages in a negative way. Now, it doesn't really matter how hard you try to convince them, as long as your message is not positive, it's going to be against you. Now, I experienced that. I was very frustrated by the fact that I've seen our team doing mistakes because they didn't listen to me. And then I just realized that it's all about me. I need to change, not the other side. So instead of coming and saying how bad it's going to be, I started saying how good it's going to be if they're going to choose the solution that I proposed or any other act or action that I wanted them to follow. And that's something that really, really helped me. Next thing. So now I want to share with you a part of Disney movie Toy Story where everything that I just talked about is coming into reality. This example from Toy Story, there is a scene that shows everything that I just talked about. And what do we see in the scene? We see Wendy speaking with Kaboom. Basically, she wants to move from one side of the store to the other side of the store, and she needs the help of Kaboom. But Kaboom, at the moment, is in a really dark spot. It's really hard for him to believe in himself and make it happen. So what does she tell him? During the scene, what she's telling him is that she's starting with a sense of importance. She's telling him, you're the only one that can help us and crash into the cabinet. Without you, we won't be able to do that. The second thing that she's doing, she's looking into through his lenses. She's telling him to believe in himself. She understands that he's in a difficult spot at the moment, and she's talking him out of it through it. And the last thing that she's doing is she's being positive about that. She's telling him that he's the greatest. He's the only one that can do that. He's going to nail it, and it's going to be amazing. And by doing that, she convinces him to go in her path, help her achieve her goal, the solution that she wants to take in order to solve the situation that they are in. And he's accepting this, eventually getting out of the difficult spot that he's in order to help her achieve her goals. So what we're seeing here is a live example, and if you haven't seen this movie, I really recommend you to do so, and go and watch this specific scene that shows exactly how the tips that I just gave are becoming a reality in this scene and convincing him to help her. Something that is very important to remember is that every mistake that you make is progress. So at the beginning of this talk, I showed you a very successful attempt of mine to do handstands, but what I didn't share with you is all the attempts that I've made and I didn't succeed in. So here you can see me falling. This was an unsuccessful attempt, but from every attempt that I had, I learned what I'm doing wrong, and I improved. And also in your way, you need to remember that up until now we spoke about, the happy flow. And it's important for me to also remember that there are unhappy moments in this process, and they will happen. But that doesn't mean that it needs to discourage you. On the other hand, you need to think, what did I learn from it? How did I get a step closer to my goal? And I'm going to improve from now on, and not discourage you to stop walking in the path that you drew for yourself. What's going to happen tomorrow morning? Tomorrow morning, you're going to wake up. I will not be there. You will remember some things from my talks, and doubts about yourself and the way and whether you're as good as you think that you are going to come up. And it's very important to remember that this will happen along your entire process. My journey, as you can see, up until now took 8 years. You can imagine how many mornings I woke up, looked at the mirror, and had these doubts. And you need just to accept them and be very actionable about them, right? Why are you feeling insecure about something? What is the doubt that is coming up? Is it, I'm not technical enough? I'm not professional enough in something? I need to learn something more in order to be the best in it. I need to be the best in it in order to be successful. All this will come up. And then there are two things that we need to remember. One, assumptions, right? Because it will keep coming up. We will always think that we need to be better than we are. It doesn't mean that it's true. Maybe we do not. And the other thing is, after we've tested the assumption, is be actionable about it. What can I do in order to tick this box that now is stopping me in the way to my success? This is another key milestone, another point in my roadmap that I just need to complete in order to move forward. So this is kind of like the other side of things. We were very positive, but it's very important also that this will happen during the way. So a quick summary for us to review everything that we've discussed today. If you could take a few things from today, here are the 3 things that I would like you to take. The first thing is have a clear goal, understand where you want to go, and set a roadmap. The second thing is convince people to follow you through all the different examples that I gave. And the last one is to stay connected to ourselves, convert fears to actions. Now, I want to leave you with something for the end of this talk, and I invite you to write your goal. Just open your cell phone, the notes, write your goal and first step, and already set a reminder for next week to follow up on what you wrote to yourself, and make sure that you're already starting your journey to where you want to be. If you want to reach out with any question, please feel free to do so via the email address that is written below or through my LinkedIn account. And yes, we are also hiring. Thank you very much. I enjoyed to be part of this amazing conference.
Hi everyone. So when I realized that I can create my own schematics, I was super excited, and I hope that by the end of this session at least one of you will be excited as I was, or at least as this kid. So my goal in this talk is that you get familiar with the things that we can do with schematics and how it can serve us during development. So let's start. So what do I need to do in order to create a new Angular component? I need to create the class file, the template, the style sheet, and the spec file for unit tests. Then I need to set the component decorator and declare my component in the relevant module. So it's a lot of preparations for a single component, and we haven't started to write the logic yet. But some of you probably think, wait, but I'm not really need to do it by myself. So you're right, you can just run this command, ng-generate component with your component name, or in short, ng-gc, and it will do all the initial setup for you. It will generate the files, declare the component, etc. So this is one of the schematics that Angular provides us, along with a long list of schematics that help us create the Angular building blocks very easily, like component, service, directive, pipe, resolver, and many more. Pretty helpful, right? But is it enough? How many times did you have to do some more setup work on those generated files? And let's see some examples. So you probably had a chance to create a service that performs HTTP calls. So you needed to inject the HTTP client provider in your constructor. So how many times did you inject it as HTTP? And how many times did you inject it as HTTP client? We are dealing a lot with observables in our components, and sometimes we need to unsubscribe for multi-observables in a component. So one option is to close them one by one in the ng-on-destroy lifecycle method, and another option is to create a field that will gather all the subscriptions together and close them all at once. So what is your project best practice? Is it the first option, the second one? Maybe it's another option, or maybe you haven't decided yet. Another example is form component. In order to create a form in our component, you need to do a few things. You need to set the form class member. You need to initialize it on init. If you're using form builder, you need to inject it in the constructor. You need to set the form tag in the HTML. And if you're doing unit tests, you probably need to inject something in your spec file, like reactive forms module. And there are many more examples. And when I encounter one of those cases, I started to feel that I'm wasting my time. The time to realize what is the right convention, to find another piece of code to copy from. A lot of PR comments to new hires, for example. And all kinds of patterns that repeat over and over, and we need to write them manually. So I asked myself, maybe there is a way to change the built-in Angular schematic, to change the template that it generates our files accordingly. And I realized that the answer is no. You can change that template, but you can do something much more powerful than that. You can create your own schematics, ones that will fit best your project conventions, your project best practices, ones that will reduce the time that you are spending on copy-pasting, on generating files, that will help you be more productive. And actually, it's really cool, and I'm sure your team members will be grateful. So hi, my name is Mai, and I'm a front-end developer at Next Insurance, and I've been using Angular for the past 7 years, yes, since it was AngularJS. So let's begin with the fun part and see some code. So first, we need to create a new schematics project. We need to install the schematic CLI, and then we will use it to generate our project using the schematics blend command. We will get a folder with the following structure, where the most important files are the collection JSON and index files. This is the initial collection JSON file. Here we are going to declare all the schematics in our library. So you can see here the first generated schematic. It contains a description and points to the schematic index file. The index file is the main file of our schematic. It contains a factory function, which receives some options, which we will talk about in a minute, and returns a rule. The schematic rule is called with tree and context. The tree is basically the virtual representation of the file system in our workspace, and the rule job is to apply changes to that tree. I think the best way to understand it is with some examples. So let's begin with a simple hello example. So first we need to create a new schematic called hello. So we are using the same schematics blend command, but in the second time it won't generate a project, but only a single schematic. So you can see it generates our index file, the index spec file, and updates the collection JSON with our new schematic. So the only thing that this schematic do is creating a text file with the content hello and some name. So we want to pass that name to our command. So in order to specify which options we can pass to our schematic, we need to create an additional file called schema.json, And here we are basically going to declare the command line arguments. So there is a single option here called name, which specifies the name of the person we want to say hello to. So the type is string, and by setting the default property here, we are setting this option as a positional option, so we can use it without specifying the name, the flag itself, meaning dash dash name. Same as the component schematic. Then we need to add a pointer to our schema file in the collection JSON file. So I'm just adding the schema property here under the hello schematic. So now we can test our schematic internally using the schematic CLI. So this is the syntax. We are running the hello schematic and passing my as the name. We also need to set the debug flag to false if we really want the changes to be committed to the file system. So let's run it. So it creates our text file with the content hello my, and that's it. So pretty simple, right? But not very useful. So remember the HTTP client example I gave before? Let's implement it. So I want to generate a service with an option to provide the HTTP client. So again, we want to create a new schematic for a service. So we are running the schematics blank command. Then we want to define what we will need from the user as input to our schematic. So the first input must be the name of the service. And the second one is whether to inject the HTTP client provider or not. So it will be the HTTP flag, which default to false. We can also create our schema interface, so it will provide us some type checking in our implementation. So I created the service options interface. I set the name as string and HTTP as boolean. So now we need to define how our generated file should look like. So first, we need to create a files folder inside our schematic folder. And then we need to create our template file with that very long name. So let's stop for a minute and explain what's going on here. So the name is one of the options we can provide to our schematic. It's the service name. And the double underscore separates the dynamic content from the plain string, which is .service.ts. The dash arise is the helper function from the Angular dev kit, which will receive the value of the name variable and convert it to kebab case string. So it's useful for file names. So for example, cool name in Pascal case will become cool-name. And there are many more helper functions in the Angular dev kit. Dash arise, classify will convert it to Pascal case, so it's useful for class names. Camelize, we convert it to camel case, and so on. So let's return to our template file. So writing the service template should be a pretty easy job because it should look the same as a basic Angular service, except for all the dynamic content. So what we have here? So first we need to handle the service name. So we need to use the name we provided to the schematic and to convert it to Pascal case using the classify helper. The delimiters in red are part of the template syntax, which used to write value of some variable. Now we want to inject the HTTP client provider only in case the user provides the HTTP flag. We can execute some code like if-else blocks. Within the delimiters you see here, it's without the equal sign. So we are importing the HTTP client and inject it in the constructor only if the HTTP flag is true. So our template is ready, and the final step is to implement our schematic rule. So basically what we need to do is to process our template files. So we get the files under our files folder, and we need to provide all the methods and properties we used in our template. So we use the classify and dash arise helpers, and of course we want to pass the user input to the name of the service and the HTTP flag. Then we need to commit our changes to the file system. So we are using the merge with rule to merge the template source, which is the virtual tree, with our physical file tree. So let's execute our schematic. I want to create a service called user profile, and I pass the HTTP flag, and this is the result. Here is the name of our service, the HTTP client import, and the HTTP client provider. So one more thing that I found very, very useful is the ability to extend an existing schematic. So for example, the built-in Angular service schematic create both service class and spec files. So if I want to redefine only the class file, as we did before, I don't have to create a template for the spec file too. I can just extend the default service schematic using the external schematic rule. The chain method allows us to combine multiple rules into a single one, so that we can perform multiple operations in a single schematic. So until now, we execute our commands using the schematic CLI in order to test it internally. In a real project, we want to integrate it with Angular CLI, so we could run it the same as we do with default Angular schematics. So we won't cover it in this talk, but it's super easy and you can find some examples in my GitHub. I put the link at the end of the presentation. So what else can we do? Create files. So we covered how to create files, but if it wasn't clear, you can create any files that you need with any extension. And even more than that, it's not have to be your client files. It can be files in your server folder, in your end-to-end, whatever. Modify files. So you can also remove, rename, overwrite. And the most useful thing is that you can update the content of existing files. Extend other schematics. So we saw that you can extend an external schematic of another library, but we can also extend a schematic that lives in our library internally. ng-add. So sometimes you need to do some initial setup when you are installing a library. The add schematic is sometimes supplied with that library, so you can do ng-add and the library name, and it will install it and do that setup automatically. So that setup is implemented as a schematic. So now that you know how to write schematics, you can add the ng-add support to your schematics project or to any of your other internal libraries. ng-update is similar to ng-add, but used for upgrading libraries. Sometimes when we upgrade a library, we need to do some migrations. So it can be automated too by implementing the update schematic. Unit tests. So yes, you can also add unit tests to your schematics. If you remember, when we created a blank schematic, the spec file was generated too. And I don't need to say why you should write unit tests. So there is a lot we can achieve by writing our own schematics. The main thing is that we can focus on the actual development. I hope that by now you already have some ideas about how it can help you and your team members. And if not, try to catch those moments that you are copy-pasting too much, or you are giving or getting PR comments on conventions or best practices. And actually it's pretty easy to implement too, so try it. The examples we did and many more on my GitHub, so you can check out my repository. Feel free to reach me if you have any questions, and thank you.
This is truly an amazing time for all aspiring front-end developers. There's a variety of courses, educational materials, tutorials, mediums. Seems like endless blog posts and articles sprout like mushrooms after a rain. Many people took this opportunity and successfully taught themselves the craft of front-end development. Surely, most of them quickly began writing features, fixing bugs, architecting their code. After some time, the lucky ones had a chance to see their own features in a live and deployed code. Somewhere on the internet is a web app, a portal, or just a regular website. A truly exciting moment, especially for junior devs. How many of them, or you, ever raised the very important question? We developers create the app, but what magic puts it on the internet? Common thinking is that it's also done by developers, just more senior or educated ones. Some of you might hear of DevOps, cloud managers, sysadmins, and other intimidating roles, living closer to some magic realm as opposed to our mortal planet. Well, that's true to some extent. Everything that happens after coding and a successful QA is often associated with the dark arts of scripts, Linux commands, and container-ish black magic. And there is this unwritten law that only the most experienced and trusted developers in the organization are responsible for the successful delivery. Should it be this way? It certainly makes sense. After all, it's a complicated and largely critical task. But does that mean it's a knowledge reserved only to the handful of positions? No, it's not, and I'm here to explain you why. As front-end developers, we could blissfully ignore this aspect and go on believing everything will be done by other magicians. But we shouldn't. The IT world is changing at a great pace, and soon this knowledge will make you more valuable and confident as a developer, regardless of whether you're a front-end or a back-end developer. Writing code is just one piece in the grand scheme of software production and deployment. Let's try to list the steps to ship any product. Let's focus on what happens after the main development phase. Why is it important? Because it can be complicated. Imagine a web-based application with a certain number of features. Let's assume the version release cycle is designed in a way that the app will be deployed to the web periodically, one feature after another. We can assume that every functionality is tested before being shipped to production. Thing is, we probably won't employ just one programmer to do the job. Features will be coded by a team. Those assumptions also imply that apart from every developer's local environment and the final production environment, it's a good idea to have a staging server to push the features into, for testing reasons mainly. Now we're getting closer to the schema like this. As you could see, things are getting complicated, and quickly. Assume that a front-end developer needs a few minutes to build an app. Caring about the code quality, he will need to run linting, run unit tests, integration tests, and possibly other checks before marking their part as done. This takes time. Finally, putting the completed bundle on the server takes another couple of minutes. Now, who wants to take care of manually deploying every single feature? What if there are 5 new features tested every day? And what if there are 50? Depending on the scale, it should certainly take more than one full-time employee just to handle those tasks. This is where the CI/CD process comes into action. Before we talk about software solutions that will build, test, and deploy our code, let's become familiar with those two terms that describe this process. The continuous integration, aka CI, is an idea that covers repeated testing of our app's integrity. From a technical point of view, it means we need to constantly perform linting, run tests, build the code, and so on. And by continuously, it means this must be done during every new code push, automatically. For example, the CI process can define a batch of unit tests that will run with the code. As part of a pull request, every time new code is added, some machine will check whether it meets the standards and contains no errors. The continuous deployment part, the CD, usually covers everything related to the process of deployment and moving the application to the desired environment. also automatically. For instance, it can fetch our app's code from a specific branch like master, build it using the proper tools, Webpack, Babel, and so on, and deploy it to the production, staging, or any other needed environment. Those two terms are separate concepts with the different origins behind the software lifecycle idea. But in practice, they're often complementary processes living in one large ecosystem. Now let's go back to our imaginary project and see how we can use GitHub Actions to kickstart our CI/CD. GitHub Actions is a new tool to perform the CI/CD process. Introduced in October 2018, launched in beta during August 2019, and stable since November. Let's have a look on an open source project which uses GitHub Actions for its CI/CD process. First, we enter the GitHub project and access the Actions tab in order to start editing our workflow files. Here you can see a list of successful and unsuccessful action runs. The default workflow file is called main YAML, which is located in the GitHub workflow directory. We can have different files with different workflows. Each of them will represent an automated flow you wish to perform. The action syntax is based on a YAML declarative configuration syntax. In the previous screenshot, some of you might notice the action store on the right. This is the actions marketplace. Actions are building blocks that power our workflows. A workflow can contain actions created not only by you and your team, but by the community. There are more than 9,000 source actions in the marketplace, and it keeps growing every day. Now, let's check the content of our workflow file. The setup of a workflow file is defined by triggers. It can be a push, a commit, a PR that opened, and so on. You can see the branch we want to execute the action on. The machine we are running on can be Ubuntu, Windows, Mac, or any other common option. One last but not least thing to remember that we have jobs and steps, which are the main core of a workflow file, which are the tasks that we wish to perform eventually. In this case, we are caching our source files. Now, the workflow is set to go. When we upload code to the repository, our workflow will run. It will access the Actions tab of the repository again. We can see runners and the logs output of our workflow steps. When no errors had occurred, we obtain the following. We can also see what happens when an action key input wasn't passed. This is the most basic failure log example. Every workflow run generates a real-time graph that illustrates the running process. You can use this graph to monitor and debug your workflows. Here you can also see a summary of the action runner. Link directly to the commit which triggered it, displaying a full summary of the workflow's data. GitHub's all-in-one-place agenda allows us to be able to watch the whole CI/CD process fail or succeed directly in your PR and your repository, without using any external tooling or any additional setup. It's important to understand that the resources you get when using GitHub Actions varies according to the plan you are registered in GitHub. The good news is that you can try GitHub Actions for free as a freemium account with limited resources. And the great news, GitHub wants every open source project to be productive. So Actions are free for the 40 million developers on GitHub to use with public repositories. So there are numerous of tools to choose from in order to configure and perform the entire CI/CD process in your app, which you probably heard of, such as Jenkins, Travis CI, Circle CI, TeamCD, and so on and on. So why GitHub Actions? Well, GitHub Actions is a new player in the group of CI/CD tools available to us. Therefore, it's necessary to understand how it evolves against his competitors. There's no need for additional setup or configuration, it comes out of the box with GitHub. We don't have to wait for one job to finish before the second one starts. No webhooks, APIs are needed to set up GitHub Actions. It works on any common runner environment in the market. It has a huge evolving community which produces new actions every day for a plug-and-play experience. And there's no need to switch other screens, connect to any virtual machines, and so on. So the true value of GitHub Actions brings the simplicity and flexibility to all developers. So I'm Rochelle, and I'm a front-end developer in Cloudinary. GitHub Actions changed the way I look on my day-to-day development experience. It provided me the freedom and confidence to deal with the infrastructure aspect of software development without being a DevOps, without being a sysadmin, or any other position. So in my free time, you can find me in solving a Sudoku in the closest dogs park with those two dogs. So for more details and information about GitHub Actions, try their documentation. It's amazing. They have an interactive playground, they have great docs, and it's just a wonderful way to kickstart with it. So thanks for your time. Feel free to contact me with those details.
Did you know that the kangaroo's pouch provides to the kangaroo's baby a safe environment from the outside world? This is exactly the purpose of the Shadow DOM, encapsulate the application from the other page. Nice to meet you all. My name is Noah Wittenstein. I'm a front-end developer at the experience team at Minute Media. In my free time, I like to bake, travel, and paddle on a surfboard. My team specializes in standalone products that are React-based. Our main product is a video player. We provide to website hosted by another party an end-to-end video platform within injectable video player in those hosted websites. Since we don't have any control over those websites, we encountered many problems in the player's implementation process. We can see here in this example, our video player is injected and looks as it should be into one of the websites. Suddenly, we noticed on that website, if we will take a closer look, that the player controls are not in place. Its size is not as it's supposed to be. The player's title is gone and a lot of black spaces. So the player's CSS is broken for some reason. But why? We found out in the hosted website, suddenly the following style tag appears. It is a CSS selector that targets all the div elements in the DOM and applies a margin bottom with 40 pixels to each div element. This style tag is within the HTML document and thus the DOM, so it affects the whole page as well as our player. And as a result, the design of the player looks terrible. So what can we do? Therefore, we needed a solution for encapsulating our code. We want the player's markup structure, style, and behavior to be isolated from the rest of the page. We want to allow CSS scoping. It means that the style will apply only to the player and page styles won't affect it. How about iframe? What is an iframe? Iframe is an HTML document embedded inside another HTML document on a website. How an iframe solves our problem? The player is not affected by the code of the hosted website, and it's shielded from the rest of the page's code so that we don't have to worry about the behavior problems or styling leaks. Now, the CSS of the player will be safe, and the player's code will be encapsulated. It sounds good, so why not use an iframe? First, accessing element in an iframe from the parent document is complicated by design. The DOM elements are in a completely separate context, so you need to cross the iframe's DOM to access the values you need. Secondly, imagine creating a page using a set of 6 iframes that each contains one component. The resulting markup would be filled with iframe tags, producing markup with low semantic meaning that is also hard to read and manage. Lastly, the iframe itself is a separate document, so the page has to download and render the iframe document, which requested assets such as JavaScript and CSS. Thus, the iframe initialization is slow and heavy. When we set up an iframe, we need to send messages from the iframe to the host page to communicate events back and forth. For example, if the user resizes the window, we need the parent to tell the iframe. This kind of message takes time, and when we are trying to increase front-end performances, eliminating those messages would be a great improvement. What can we do? Let's use a shadow DOM. So, what is a shadow DOM? It's simply a DOM inside another DOM. It has its own isolated DOM tree with the elements and styles completely isolated from the original DOM, allowing us to keep the markup structure, style, and behavior hidden and separate from other code on the page so that the different parts don't clash and the code can be kept nice and clean. A shadow DOM, as its name suggested, is always attached to an element within a regular DOM. Without the DOM, a shadow DOM does not exist. The scoped CSS alone is incredibly powerful. The CSS defined inside of the shadow DOM scope to it, and it has its own style sheets. Style rules don't leak out, and page styles don't bleed in. The scope DOM simplifies the CSS, which means you can use simple CSS selectors, more generic IDs, or class names, and not worry about naming conflict because the shadow DOM is isolated from the rest of the DOM. All the shadow DOM does is to wrap our encapsulate application and therefore the semantic meaning remains the same. For example, if we want a button that allows the user to select a file, the obvious starting point will be a form input. So now we decide we want to use an icon. Instead of the boring choose file button, the shadow DOM allows us to encapsulate an icon under another element, in this case an input, without changing the functionality or the semantics of that element. Since the shadow DOM is native to the browser, its initialization is much faster than iframe since it won't require any tools. iframe requires a title, otherwise screen readers announce them simply as iframe. Shadow DOM has no such requirement as it's native to the page. Whenever we look at a cool new browser APIs, we have to also consider support. Luckily, Shadow DOM is supported in all major browsers, except Internet Explorer, which you can use a polyfill to support the Shadow DOM. Shadow DOM is amazing. However, it's not all sunshine and rainbows. We need to consider that the Shadow DOM is not visible to the document query selector and document query selector all. Therefore, if you would like to start working with Shadow DOM, you will need to rewrite in the code all the use of document query selector and use shadow root instead of the document, which I will explain later what a shadow root is. Even though the shadow DOM is shielded from the outer style, some styles like color, font, and line heights are still inherited in a shadow DOM. To ensure a full encapsulation, we will need to use all initial, or preferably all revert, because it has a better browser support. The CSS all property resets all properties to their initial or inherited values. We will apply the all property on the wrapper of the inner shadow DOM. How the shadow DOM works behind the scenes. In this diagram, we can see the document tree with the shadow DOM host attached to it. Shadow host is a regular HTML element within the original DOM that we want to attach the new shadow DOM to it. Let's take a look at the part where the shadow DOM is attached to the shadow host. The place where the shadow DOM ends and the regular DOM begins is called shadow boundary. The shadow root is the start of a new shadow DOM in the way that HTML tag element is the start of the original DOM. The shadow root is the root node. Shadow DOM creates a scoped DOM tree that is attached to the shadow host. This scoped subtree is called a shadow tree. You can affect the node in the shadow DOM in the same way as non-shadow nodes, for example, appending children or setting attributes. The difference is that none of the code inside the shadow DOM can affect anything outside it. How can we create the shadow DOM? It is a great and powerful tool that can be easily created. Let's take a look at the code. We can attach the shadow root to any element using the attach shadow method. It will create an empty shadow root as a child of our shadow host. The attach shadow method takes as its parameter an option object that contains one option mode with a value of open or closed. Open mode means that you can access the shadow DOM from outside using JavaScript written on the main page. We can do that using the shadow root property of the shadow host element. It will return the shadow root object. Closed mode means that you cannot access the shadow DOM from outside using JavaScript written on the main page. Thus, the shadow root property will return null. After we have attached a shadow DOM to an element, manipulating is just a matter of using the same DOM APIs as we use for regular DOM manipulation. In this code, for example, we created a div element and appended it to the shadow root element, just like we append children in a regular DOM element. Let's take a look at the HTML structure of the shadow DOM as it appears in the DevTool inspector. As we can see in the player's HTML structure, the div with the class name Vortex placeholder and player is the shadow host. Underneath it, we have the shadow root attached to it with the encapsulate code of the player, which is part of the shadow tree. After we learn so much about shadow DOM, let's sum it up and see when should we use shadow DOM. Firstly, as we saw in the player example, standalone application with its own set of functionality hosted on website is a good candidate for shadow DOM. With this in mind, we should think about what shadow DOM could solve for us. While both iframes and shadow DOM provide encapsulation, The Shadow DOM avoids the completely separate context, setup overhead, and clunky markup that occurs with iframes. Twitter used it to change their share this tweet feature. They changed it from iframes to Shadow DOM primarily for the speed boost. Thank you so much for listening to me. If you have any question, please feel free to reach out.
We are all familiar with the Dyson vacuum cleaners, which come along with several different cleaning heads. We have one head specified for vacuuming the sofa and another one for the floor. So we have one device vacuuming different surfaces using different heads. This is exactly the idea behind creating a generic plugin system. Hello, my name is Chen. I love to travel, go to the beach, and work out a lot, as you can see in the picture. I'm a front-end developer at Minute Media. I'm currently part of the core team, but before I was part of the CMS team. CMS is a content management system, a software application that enables users to create, edit, publish, and store digital content. When we want to create and share information, ideas, and news virtually, we use social media. Posting attractive visual content and videos make content much more interesting and engaging. For example, what a better way to talk about the new bizarre Netflix show than sharing the trailer and expose it to whoever familiar with it. As you can see, the trailer in this article is an embedded YouTube content. In order to do that, we need to add to our CMS the ability to embed content. We started by connecting our system to YouTube by creating an embedded YouTube component. Afterward, we decided to add Instagram to our store system. So we created an Instagram embedded component by doing the same thing we did when we created the YouTube component. Then we also had Twitter, so we needed to do it all over again. At this point, we realized our system will continue to grow with more embedded components. The result is code duplication. We decided to create a generic plugin system, a system that allows the growth of the product for future need with minimum effort, providing extensibility and flexibility. So how do we start to create a generic plugin system? First of all, understanding the system flow. Every plugin has the same general flow. The user inserts the relevant URL. Then we get the embedded data from the plugin server and process the data to a preview block. Once the user approves, content will be shown on the article page. Secondly, we need to choose the format that will support various of the plugin features. In our case, we choose the OEmbed format. And then we choose 2 to 3 cases and compare between them to understand what is similar and what is different. If we take, for example, YouTube and Instagram, there are a few similar things. Getting the URL from the user and checking if it's valid, fetching the relevant data, process the data by running some script, creating the preview data block, show an iframe in HTML. The differences are the server that we are fetching the data from, the data structure that is returned from the server, and the script that are required for processing the data. The final step is designing the system. At this point, we need to stop and think which feature should be implemented as part of our generic solution and which should be developed as a standalone solution. The plugin system consists of 2 components, a core plugin system and the plugin component. We are creating the plugin component according to the similarity and differences we saw before. Let's take a look at the UI system. We can see that we have one system that contains all the plugins. Clicking on one of them will take us to the relevant plugin component. We will create a generic plugin component that has the URL input, the preview block, and the add button. Here you can see, for example, the preview block for Instagram and YouTube. The component will receive from the outside what is different for each plugin. In addition, the component will take care of common code being used by multiple plugins to avoid code duplication. In our case, when there is a server error, all the plugins will show the same error message. In this case, you can see we are passing YouTube data to our plugin component to create a plugin instance. And this is what each plugin needs to do. After the plugin component implement is done, we need to implement our core plugin system. This system will host all the plugins and will be in charge of rendering the selected plugin component. Each one needs to register itself to the system. The way to do it is by adding the plugin type and its render function to the core system. Now, every time we want to add a new plugin, all we need to do is just send the relevant data to the plugin component and register it to the core system. Although generic systems have many advantages, we need to make sure we are not over-engineering the system. So how much generic is too generic? The resultant code becomes much more messy and complex than it should be. The code doesn't add stability or improve maintainability. The system includes very unlikely scenarios. You should not take into consideration a possible need if you don't know about. When a system becomes too large, besides having a negative impact on the performance, the system typically becomes more complicated to use. The system API will be more extensive. This requires more knowledge of the developer who is using the system and make debugging harder as more things can go wrong. Developing and debugging the system itself becomes harder as one needs to account for more and more edge cases. We need to remember not to add specific implementation to our generic solution. If it doesn't fit, don't try to force it. For example, let's take the URL prop for the plugin component. We decided the URL validation should be done inside of the plugin component, based on the idea that every URL has the same basic validation. Facebook decided that their URL cannot end with a number. To support these changes, we added the if end with num flag to the component interface. Now, we need to add another URL validation in case this flag is true. Then, Instagram decided that their URL must include the word Instagram. So now, we will add another flag called should contain Instagram. We can see that our validation functions start getting big and complicated. We started by checking the basic validation. Then, we check if the two conditions are happening, and if so, we check their validation. If both of the cases don't happen, we need to check only the relevant ones. We can see that we have a lot of if statements that we need to check, and on top of that, they are irrelevant to all other plugins. We can understand that in this case, it is better to send a URL validation function from each plugin to the component, and the component will run it when needed. Today, this plugin system allows us to add a plugin in minimum effort, providing extensibility and flexibility. At any given point, we can add, remove, and change existing plugins with minimum or even not at all effect on the rest of the core system or other plugins. In addition, the process of adding new plugin is almost effortless. To summarize, there are several cases when we will need this generic design. Increase the efficiency of the code when we have a lot of code duplication in our system. When we are designing a system composed of many components which may interact with each other, the system should be dynamically extended to include new plugins. Since the plugin ideally provide a well-defined interface and documentation for plugin writers, developers have a clear roadmap for development. For my personal experience, the plugin system helps us to handle complexity, simplify application configuration, and deployment. It may have taken us longer to develop at first, but it saved us a lot of time in the long run, so it was worth it. Hope that you enjoy my presentation, and next time when you want to implement a plugin system, it will help you. For any more questions, feel free to reach out. Thanks.
Have you ever tried to start building a puzzle from a random piece in the middle? It will work and you will be able to finish the puzzle, but it will probably take you longer than if you would choose to go in a certain pattern. For example, start building the frame and continue from there inside. The same thing happened when creating components in React. We can build components in different ways, but there are specific patterns that can help us to do it in a more suitable way. One of these patterns is the compound component pattern, which I'm going to talk about today. Hi, my name is Adar. I'm a front-end developer at Minute Media. I have a bachelor degree in computer science from Ben-Gurion University. And for the past 1.5 years, I've been a part of the core team, who among other things is in charge of the company components library. A few months ago, I was given a pretty simple task: to create a selectable card component. Every time I need to create a new component, the first thing I'm doing is understanding what should be the component API. Our card should have a title, an image, a short description, and an is-selected prop in order to allow the user to control if the card is selected. When using React, we always need to think about composition. We don't want to have huge render functions that are not clear and readable. Instead, we want to build smaller, simpler, and reusable components and combine them together into one main component. So I split my card into card header, card image, and card content. Let's take a look at the code. Here we have the component props and the component state, Boolean that tells us if the card is selected or not, and our render function that contains the card header, the card image, and the card content. Let's take a look at the card header component. We have all the props that we receive from the parent. We have a checkbox for selecting or deselecting the card. And we have our title. And this is how the user will use our component. He will just pass all the props to the card. Great, our component is working and we are ready to release it. But then the design team came to me and asked if we can also support showing the description above the image. So I went back to the card and added description on top prop. And now this is how the render function looks like. We need to check whether to render the description before or after the image. And if it was the only new case, I guess we could leave it like this. But we started to get more and more new cases. We need to add closable option, add optional footer, and so on. At this point, I've started to feel that maybe this is not the best way to implement the component. As my API got bigger and bigger, and my component began to fill up with more and more props and if statements telling it how it should render. One of my teammates suggested that I try to use the compound component pattern, and that was exactly what I was looking for. What is a design pattern? It is a general, reusable solution to commonly occurring problem within a given context. As React was getting more and more popular, people start facing the same problem. So there was a need for design patterns that will help us overcome these problems, fasten our development time, and help us to create more clear and easy to maintain code. The compound component pattern allows you to create components that work together and have a shared state. In order to understand it, let's first see how the user will use our new implementation. Not like our first implementation, here the user needs to pass multiple components as children. These are all the subcomponents that make up the entire card. The card needs to receive only the props that are relevant to the entire component behavior, the ones that we need to share with multiple children. And each of the subcomponents receive only the props that are relevant to it. In our case, the header will receive only the title. The image will receive only the image source. And the content will only receive children. As you can see, I'm using the dot notation here. Instead, we could just export all the child components one by one. But since it doesn't really make sense to use these components outside the card, in my opinion, this export is more clear. Also, the user only needs to import one component in his code in order to use the card. Now, if the user wants to render the content above the image, all he needs to do is to change the order of the children. Let's see our new implementation. The first thing you should notice here is that the card component receives children, and just rendering them inside, it does not care which children it received or in which order they are. The second thing is that we are wrapping everything with context provider. If you are not familiar with React context, it is a way of passing data between components through the components tree without passing props down to every level. That means that every component that is rendered inside the card will have access to the context value. In our case, it's the isSelected flag and its setter. This is actually our shared state. Both header and image component are using it. Let's dive inside one of our child components, the card header. Since only the header needs to use the title prop, it is now part of the header API and not part of the card API. In order to access to the shared state, we are using React Use Context Hook. The hook receives a context object, the one we created in the card component, and returns the context value. The rest of the component remains as it was before. Inside the other child components, we are doing the same thing. Each component has its relevant props as part of its API, and they all use context hook to access the shared state. So what did we achieve from using this pattern? One of the most common and annoying issues in React is prop drilling, when you need to pass props from the parent component to a child component, and the child needs to pass it to his child, and so on. Using this approach, we avoid that issue, since all the shared state is passed to the children using React context, and each component receives props directly from the user and not from the parent. Since the user is now in charge of placing the component children, he can place them in any order he wishes. We don't need to have props telling the card how it should render anymore. It is very clear what is the responsibility of each of the components. The parent component is in charge of managing the shared state, and each of the child component is in charge of its own UI part only. If we want to add another component to the card, for example a footer, we don't need to change the other component's code, not even the card itself. Having a component that receives too many props is usually more difficult to work with. Using this approach, we are not passing all the props into one big component. Instead, we are passing each component only its relevant props. We all know the famous phrase, where there is a great power, there is a great responsibility. We should always keep this in mind when using this pattern. Providing this much flexibility can sometimes lead to unexpected behavior, especially in the component loop. So we need to make sure that we are using it in the right case. So when should we use it? In components where you want to give the rendering power to the user, but still have all the component logic managed within the component itself. Good examples for components like this are dropdowns, tabs, accordions, and box components like modals. And I want to finish with some tips or steps on how to refactor a component to this pattern, after we decided that this is the right pattern for us. First, we need to understand who the child components should be. What are the smaller parts that make up the entire component? These are the parts that we want to allow the user to place in different orders or that are optional. The second step is understanding what should be the shared state, which data is relevant to the entire component. This state, along with its logic, should be managed within the parent component. And then we can start creating the APIs for each of the components and implement them. Hope you will try to use this pattern in the future, and maybe like me, after doing it once, you will want to go and improve other components by using the compound component pattern. Thank you, and if you have any question, please feel free to reach out.
Hi, my name is Revital Keren, and I'm a front-end architect in the core team at Minute Media. My interests are digging into record shops around the world, beautiful, tasty avocados, and front-end development. Today, I want to share with you a story of how we decided to create our own framework instead of doing just another copy-paste to a working project. I will show you how we built our Voltex management system, also known as Buffy because it effing slays, where our partners can view and manage their content, be it written or video content. Each one of the entries in the left side menu is what we call a sub-application, like the editor for creating and editing posts, the publisher for publishing posts to feeds, the videos for uploading and managing video assets, etc. When we started our Voltex management project, we initially needed to bootstrap, wire up, and configure all the necessary tools and libraries. And there were quite a few. And then some. Only then we were ready to write each sub-application's code and add it to the project. And every sub-application that was added to the project needed to be wired up and connected to the various components, like the router, the store, and the navigation. Every single time. Plus, it was hard to maintain a standard of writing and file structure inside each sub-application, as each team was responsible for its own sub-application. We started suffering from maintainability issues and a lot of copy-pasted code as a lot of new teams and new developers entered the project. What a mess it was. And that wasn't our only problem. We've also received a new requirement for more management applications, but this time for internal company users only. That should not be part of our original project at all. What do we do now? Do we add these unrelated sub-applications into our project? No, they really don't belong there. It's different users with different needs, and the code will most likely need dependencies that our project does not even use. Do we go through all of the project initial setup from scratch? Oh no, that means suffering from the initial wiring up and configuration pains of the project all over again. And then also suffering from the wiring up of each sub-application to the project. Or maybe we should just copy-paste the original project and remove unnecessary code from it. Hell no, there must be a different solution that will give us what we really need. A way to facilitate the process of spinning up a new project like a black box and abstract the wiring up of new sub-application into the project, just like plug and play. Why not have a framework from which all projects will be created with a single command? And each new sub-application we want to add to it can be created and added also with a single command and wired up automatically. So let's look at the definition of a framework by Wikipedia. A software framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code, thus providing application-specific software. It provides a standard way to build and deploy application. Okay, wait, let's break it down a little. So it's an abstraction, provides a standard way, reusable software environment, facilitates the development, and it includes support by programs, compilers, code libraries, tool sets, exactly what we want. So what are the signs that tell us that this might be a good solution for our problems? When we find ourselves repeatedly copy-pasting projects code, when we have a lot of repeating infrastructure tasks before we even start writing code, when we need to enforce file system structure and coding conventions and standards in our projects, when we have a lot of teams touching the same code base or creating similar projects and a lot of new developers onboarding, or when we know that we have some more of the same projects coming our way. So how do we create a framework? Our final goal is to create our own framework according to our needs. By following these steps, you can eventually run a single CLI command to spin up a new project containing your company's specific tools and standards. First, you create your common reusable libraries, like a components library, core utils, authentication, a scripts library with modules for building and deploying your project, etc. Then you create a template project, an empty project with a file structure according to your standards and your custom common libraries as dependencies. This project will be the base for any new project created. It will not contain any user or application specific code. And don't forget to add a good README file so your developers can follow and easily learn the conventions of your framework and how it works. In your package JSON, you should include your common libraries just created, like so, and some npm scripts using our scripts module for building and testing our project. At this point, you have two options. Option number one is to write your own custom script, which will use the template project we created to duplicate and transform the files according to the developer input. This is harder to maintain. Plus, you have to write it all from scratch. The second option is to use an existing tool like Yeoman, which is a scaffolding tool that allows writing and using your own generator model to scaffold new projects from your template project. The big plus here is that Yeoman already supplies models for CLI interactivity, transformation and manipulation of files, etc., without you having to worry about all of these yourself. So it allows more flexibility. It is also based on Gulp plugins, so you can use any Gulp plugin you want. They also have a great doc site that takes you step by step through writing your own generator. And Yeoman also supports composability, so we can easily choose exactly which parts we want to compose into our project and what tasks exactly we want to be performed on our sub-application. This, along with the CLI support for user interaction, is a big benefit already over creating your own script from scratch. So here is an example of using our custom generator. In order to run a Yeoman generator, you just run the command yo with the generator name. In our case, it's Puffy project. And I'm passing here as command line argument the string internal admin to be my project name. After running the command, the user is prompted to input the values needed for our project setup. In this case, it's choosing which common libraries we want to use in our project. Then what is the name of the sub-application we want to create and whether or not to connect it to the store. This is the final outcome, our project plus the sub-application created instantly. And the best part is, what previously took us between 5 hours and 3 days to create a new customized project now only takes us around 10 seconds. And previously, adding a new sub-application to our project took between 2 and 3 hours. Now it only takes around 5 seconds. That's amazing. To summarize, to create your own framework, all you need to do is to follow these steps. Create your common reusable libraries, create a template project with a good README file, and choose between the two options of either creating your custom script or creating your custom Yeoman generator. I hope that now you're not afraid of the word framework and will also consider creating your own framework to ease the development experience in your company. For any questions and thoughts, you can contact me using these links. And for all you Buffy buffs out there, this is a little something for you.
Grr, arg.
Thank you and goodbye.
Bugs beware, exploratory testing is here. Hi everyone, and thank you for joining my lecture. First, let me tell you a joke. A software tester walks into a bar. They order 1 drink, 1,000,000 drinks, 0 drinks, -1 drinks, and a lizard to top it off. Everything works perfectly. Then, an actual customer walks into the same bar. They ask where the toilet is. The bar then explodes into flames. This is exactly what exploratory testing is all about, treating the software like a real user would. So hi everyone, my name is Yana Margolin. I've been a test engineer at Google for the last 12 years. Before that, I was a QA team manager at an e-commerce startup, which unfortunately no longer exists. And I enjoy finding bugs in pretty much anything around me. You can also see my contact info on the slide. So today, as I said before, we're going to talk about exploratory testing. First, let's differentiate between a more traditional testing methodology called scripted testing and the type of testing that I'd like to present here, exploratory. In a nutshell, scripted testing is basically an execution of pre-designed test cases during the testing session or cycle. Exploratory testing, on the other hand, is more like a creative investigation of the software when test cases are designed mostly on the fly. A little to none test design is done in advance when exploratory testing is carried out. Let's see some examples which can better explain the differences between these two types of testing, scripted and exploratory. Let's start with ordering drinks. During scripted testing, one of the possible test cases would be ordering a negative number of drinks, say -1. We will then expect the bar to issue an error message, saying something like, the number of drinks you chose is invalid, please choose a positive number of drinks. During exploratory testing, however, we would carry out a test case which will resemble an actual order taking place in a bar. For example, a party of 5 people, all getting different drinks, with custom requests, such as please add extra ice to my drink, or make this cocktail without a cucumber. I personally cannot stand cucumbers in alcoholic drinks, so that could easily be me. Another use case we'd like to test is paying for our drinks. During scripted testing, a scenario such as entering all zeros instead of a credit card number might be carried out. We will then expect once again to receive an error message, something along the lines of the credit card number you entered is invalid, please enter a valid number. During exploratory testing, we would be more interested in a testing scenario, such as paying part of the bill by cash and part by credit, as often happens when a group of friends go to the bar. Our third example will be related to sitting and making reservations function. For instance, during scripted testing, we might test a scenario such as trying to reserve 1,000,000 seats and expect to get a suitable error message saying the number of requested seats is too big, please choose a valid number of seats. In exploratory testing, we might want to test and see what happens if a party of 5 people wants to move to a different table after the bill has been opened and drinks have been served. This is a scenario which often takes place in an actual bar, people moving from the outside to the inside to get some air conditioning, or switching to a better positioned table than the table they were originally assigned to. Now, let's summarize the differences between scripted and exploratory testing in a more general way. Scripted testing is mostly focused on verification of the software versus its requirements. Exploratory testing is all about software exploration, as the name suggests. Think Dora the Explorer if you're familiar with the animated series. This is exactly the concept. In scripted testing, test cases are designed in advance, and the testing begins once there's a complete test plan in place. In exploratory testing, on the other hand, testing cases are mostly designed on the fly during the actual testing. In scripted testing, the script is the king. A test case must be included in the test plan for it to be executed. If a test case is not in the test plan, it doesn't exist, it won't be carried out. In exploratory testing, the tester is the queen. Since the test plan is determined on the fly, there's a lot of room for testers' experience, intuition, and judgment. Scripted testing can be summarized as divide and conquer. Features and paths are tested separately. Exploratory testing can be summarized as unite and rule. Features and paths are integrated and tested within the same user flow. For instance, in exploratory testing, we'll start by making a reservation at the bar, continue with showing up, getting our table, ordering drinks and food, moving tables to a better location, paying the bill, and then leaving. Okay, here are all the aspects we talked about in the last few slides, summarized into one table for easier reading and screenshotting if you would like to take a picture and save it as a reference for future use. Okay, now let's see when we'd like to use each type of testing. Scripted testing is a great methodology. It is well suited for testing high-risk products, such as financial applications. This approach is very suitable when there is enough time for documentation and planning. It also ensures high test coverage and is very thorough. So scripted testing is great, but exploratory testing is invaluable. And let's see in which cases and why. The first use case in which we'd like to use exploratory testing is getting a sense of how release ready is your product. If the basic user flows are buggy, it's obviously not ready to be released. For instance, if ordering a drink in a bar doesn't work, you know that the bar still needs some improvements and some work to be done before it can be released. The second use case for exploratory testing is an agile development cycle. Exploratory testing is well suited for the agile development approach as it is more adaptable to changes and keeps up with the short Scrum cycles. A change made during the development sprint can be immediately included in the next exploratory testing session. Exploratory testing is the way to go if you have a small or non-existent testing team. If the team is small, the tester actually needs to focus on the testing rather than on the documentation. If the team doesn't exist, the developers should test the product in an exploratory fashion. It is also advised that each developer tests the user flows developed by their teammates and not the ones they themselves worked on. This ensures a fresh, unbiased look on the user flow and its potential problems and pitfalls. Exploratory testing is a great methodology to be served as a base for creating a detailed test plan later on. User flows must be a core part of the plan to ensure critical paths of the product are tested. And last but not least, exploratory testing is a great source for automation scenarios. Common user flows must be automated. This way, we'll know immediately if a bug has been introduced into any of them. Okay, taking into account everything we just learned about exploratory testing, let me ask you a question. How would you test a bar? Since this lecture is pre-recorded, let me answer the question for you and give you some ideas. And of course, this is just the tip of the iceberg. Feel free to add your own later on at the Q&A session. So first of all, of course, ask to use the toilet and make sure the bar remains standing. Critical function at any bar. Second, a scenario that you might want to consider is paying the bill by parts and at different times. Also splitting the bill unequally, tipping part in cash and part by credit. All of these are common scenarios which take place when a group of friends goes to the bar, but some leave at a different time than others, and as a result, need to pay the bill separately. One last scenario that comes to mind is the happy hour, a very common practice at most bars. We'd like to see what happens if we start ordering drinks during the happy hour and continue ordering after the happy hour ends. Do we still get our complimentary drinks if there's a 1+1 deal? What about the use case when some of the people at the table arrive during happy hour and some arrive later? Do the late arrivals still get to enjoy the happy hour discounts or not? This is also something to consider. There are many more possible exploratory testing scenarios which can be used to test a bar. If you'd like to tell me an especially interesting scenario you have in mind, I'll be happy to hear. Here's my contact info once again. Thank you so much for listening, and cheers.
Hi, my name is Jen Seinitz. I am backend-oriented developer at Behalf. I was born in Soviet Union, where I had an amazing childhood. My best memories are related to Novy God, literally New Year, the New Year's Eve celebration. The main figure of this holiday was Ded Moroz, or Grandpa Frost, the Russian answer to Santa Claus. According to tradition, every December, Ded Moroz, prepaid by my mom, visited me at my family's apartment. All I need to do to receive a gift was to tell him some winter poem. So I climbed on a stool and I blurted out all I knew about winter. And I always received a gift. Now, imagine this gift-giving schema as a software application. Let's assume our application is based microservices. At Behalf, the company I'm working for, we just made the transition from monolithic architecture to microservices. So it's kind of a bridge from my past to my reality. We have here a kid microservice, a Grandpa Frost microservice. My mom is a user. She's using a public API, a phone, to communicate with Grandpa Frost. Before this application is going to the cruel production world, it must be tested, well tested. We really don't want to upset mom because her child didn't receive a gift. Well, a bit about my high-tech career. I started my way as a QA engineer, so I have a long-term love story with tests. Long enough for experiencing the overtesting side effects. Long enough to understand the biggest challenge in testing is knowing when to stop. Based on my experience, I created some guidelines that help me to cover the feature functionality without overtesting it. But before we diving into testing water, let's take a look at microservice structure. Most microservices have the same structure. It includes some form of interface, domain, and persistent layers. When it's coming to testing, we want to cover each layer separately. We want to cover the communication between services within microservice, and we want to cover the communication between microservices within the entire application. Unit testing run on the smallest independent piece of code base. Ideally, unit tests depend on single dependency, on a single tested class, which makes this test low cost in writing, maintaining, and running expenses. Often, the low cost of unit testing lures us into the trap of overusing them. Let's assume our microservice has some kid activity service. Okay? This service is ready to be tested as a unit. It includes some telling poem activity, which calls poem service to retrieve the latest learned poem. How great a temptation to test these services together. However, poem service have its own dependencies. It depends on poem repository and on, let's say, mom's help service. Will we include these services in the unit testing boundaries? Whichever way you choose, from my experience, if unit tests depend on more than one real dependency, you will face some side effects. The setup will become more complicated. Quickly you can find yourself writing component tests using unit test tools. Changes in poem service likely will break the kid activity unit test, so the maintenance will become more complicated. In addition, the bug detection will become more difficult. The higher borders, the more places to hide. From the other hand, the overusing of mocking slows down the implementation process. So, before you're writing the unit test, consider its value versus maintenance cost. Or just follow the rules of thumb. Test only classes that execute business logic. It will squeeze the unit testing boundaries to a service layer. Try to keep your unit as small as possible. The isolation of unit from other dependencies will have positive impact on maintenance and bug detection. Now, when your unit is isolated, achieving full scenarios coverage is possible. On top of that, this is a place to cover the edge cases and the different parameters variations. So far, we have a good coverage of separate classes within a service layer. It's time to test how these classes collaborate together. It's time to test the microservice itself in isolation. The isolation in microservices level achieved by mocking integration layers, by mocking collaboration with external components. All other dependencies are real, which increase the confidence in our microservice correctness. From the other hand, it significantly slows down the compilation time. For some reason, we find it difficult to stare at the test runner for more than few seconds. Now imagine you're running 1-minute test suite. Within the first 5 seconds, you will predict the test results. Then you will check your phone notification. Then, just for a second, you will check your social media feed, where you will stack on your friend's picture from his latest vacation, and so on. Meanwhile, the test was completed, and now computer is waiting for you. I want to point here on a dual side effect. First one is a predictable test runner. Predictable test duration is multiplied by the time computer spent on waiting for us. The second is a non-trivial one, the effect of losing focus. Our service, our component testing are critical for a microservice wellness. We don't want and don't need to skip them. Unfortunately, we can't avoid this side effect called losing focus. However, we can reduce it by squeezing the test suite to the necessary minimum. The goal of component testing is to test the API message from the consumer perspective. So don't cut the corners, start each test by message consumption. Don't duplicate the scenarios that already were covered by unit testing. Try to focus on untested scenarios, on untested layers. This test will include the request authorizations, the request validation, and API-related exceptions. Component tests allow us to validate domain data storage, so include data persistence verification in test assertions. The only untested layer within our microservice is integration layer that was mocked previously. The integration layer implements collaboration with third parties, with external components. To test this layer, we have a component test extension called also integration testing. The problem with the integration testing is that you can't guarantee the result consistency. I mean, integration tests have more than one reason to fail. Maybe the external component unavailable, or maybe just break the contract. I mean, if bookstore is closed, the kite will not receive the winter poems book. For this reason, we often prefer to ignore the integration testing from the component test suite. By this ignorance, we can miss the contract break. Moreover, when we decide to unignore previously ignored tests, we can find them broken. And maybe we just made some refactoring and integration layer. It can be broken. And post-factum test modification requires more resources than ongoing maintenance. So to mitigate the flaky results problem, write only a handful tests to cover the basic success and basic failure scenarios. Okay, now we're pretty confident that our microservice works as expected. Let's continue to end-to-end testing. By end-to-end, we want to verify our application meets the requirements, our application achieved the business goals. Our mom have an ability to communicate Grandpa Frost, and Grandpa Frost coming in time, kid received a gift, everybody is happy. I mean, end-to-end tests have large boundaries. It fills the gaps between microservices. The wider boundaries, the higher the confidence. The desire to be on a safe side often pushes us to try to cover everything in end-to-end tests, or at least to try. Don't. The higher the confidence, the higher costs. So, by end-to-end testing, try to cover only scenarios that cannot be covered by component testing. It should be the additional cover for our application. Okay, so treat the application from the user perspective. The strategy is to test only business use cases scenarios. The application behavior is fully tested. It's time to summarize what we just talked about. So the goal was to test application functionality without over-testing it. We started by unit testing, when we should try to keep the unit as small as possible, and we want to limit our unit testing to the service layer. When it's coming to component, we want to cover the scenarios that weren't covered previously. And we will start by message consumption, and we will finish by persistent assertions. By end-to-end testing, we want to cover the scenarios that weren't covered previously, and we will treat the application from the user perspective. That's all. For more content, please follow me on social media. Thank you.
Okay, hi everyone. Let's start with a quick quiz. Take a few seconds and try to think if you are familiar with this device. In case you are not familiar, this medical device called pacemaker. Pacemaker is a small electrical device that implemented into patient chest in order to treat some abnormal heart rhythm, which can cause your heart either to beat too slow or miss beats. Actually, this tiny device sends electrical impulse in order to set the heart rhythm. Now, try to imagine what may happen in case that this device will have a bug or suddenly stop working. Correct. The patient heart may stop beating. Now, try to think what are the consequences in case that this event will really happen. Unfortunately, last month, it's become a reality. Over 60,000 pacemakers recalled from the market due to risk of electrical short. Over 100 pacemakers caused serious injuries for patients. People could die. 1,000 patients were at risk. Over 100 were injured. My name is Karen Sabar, and I'm quality manager at Medtronic. My job is to make sure that this event won't happen, and that patient safety will be kept during all product life cycle. I really love running for distance. Therefore, I'll take you for a short journey. And in this journey, I will explain how to implement the quality into the medical device in order to avoid the next recall. This roadmap that we will follow during our quality trip, we will shortly visit each point of interest in the design control process, and at the end, we will think together what things could go wrong in the pacemaker recall event. Our first station will be the user needs. When you had a wonderful idea for your new medical device, there are two terms that you should understand. The first one, intended use, which means what you claim that your medical device does. And the second is indication for use, which describes the disease or condition that the medical device will treat, diagnose, mitigate, including a description of the target population. All of this related to the user needs. Now, in order to get a better understanding of what user needs really are, you should ask a lot of questions. For example, let's take our pacemaker. You can ask, what do you want the device will do? And the answer will be, the device will give electrical pulse to the heart in case that no heartbeat were detected. Or, how will the user and the patient interact with the device? There are likely thousands and thousands more questions you want to ask and answers as well. Just keep in mind that later on you will need to demonstrate that the product you develop addresses the user needs that you defined. Logically, user needs are the lead to the next station, design inputs. Writing good design inputs, in my opinion, are much like art form. And like all art form, writing design inputs take practice and dedication. Design inputs define all performance criteria, device functions, safety, and all other requirements and features of your product. The primary resource that fits the design input are the user needs. However, don't rely only on the user needs as the only source for the design input. There are things like industry standards, regulations, and competitive product that you also should consider when it comes to defining the design inputs. You have to consider all types of source and resource for the design inputs. Leave no stone unturned. while user needs are broadened statement, subjective, with abstract concept that may be difficult to measure, and it's okay. Design input should be objective and measurable. Think of the user need as the precursor to the design inputs. Pacemaker example, input can be, since the pacemaker should be stable in the human body for at least 10 years, we need a suitable material to support it. Therefore, one related input may be that the battery will be lithium with long life, 5 to 10 years. Or another example is that the device should be implemented in the patient's chest. Therefore, it should be small and light. So the input may be that the weight will be no more than 25 grams and the size not more than 1 centimeter. Remember that you should consider design verification when establishing the inputs. But before jumping to the verification, we'll have a short stop in the design output station. Design output is being the recipe for your eventual product. As you get into the design and development, you start to identify all parts and pieces that are required for your medical device and define what are subsystems and components go into your medical device and how are those components put together. Your medical device is comprised of a number of materials, components, subassemblies, and so on. And each one of these should be defined and documented in things like drawing, specifications, instructions. Good design inputs make it easier to create design outputs. Output, for example, in the pacemaker is the battery specification or drawing including the actual size. Now, we will discuss two important stations together, verification and validation. When you got to design for verification, your goal is to prove that your design input met your design output. Design verification is all about demonstrating you made the product correctly by testing, inspection, or analysis. And for the house verification, we can check if the roof is red, are the windows are not more than 1 meter, if the door can be opened or closed. Design validation is about proving that you designed the correct product. In order to understand the difference, it's helpful to remember that the whole intent and purpose of the medical device validation is to prove that your medical device meets the user needs. As for the house, the user needs, we need to confirm is if it can easily get into the house, is it comfortable to live in? Next quick stop is the design transfer. Design transfer occurs after successful completion of all verification and validation, and completion of all documentation that needed for the manufacture of the medical device. Last but not least is the design change station. Medical device continue to be changed. All design change need to be assessed before the implementation. Assessment should include impact on the user, impact on the overall safety and efficacy, and regulatory impact. Now, let's get back to our tiny pacemaker, which we called from the market. Our pacemaker were in the market, which means he went through all the required steps. So let's try to think together and understand what went wrong. Before jumping into assumption and guessing where the failure may appear, let's stick to some facts. First, I will remind you that a pacemaker recalled from the market due to risk of electrical short. Now, I want to share with you that the company found out that the electrical short appeared due to moisture inside the device. And last, we should know that the moisture in the device appeared due to integrity failure, which related to the epoxy glue. Knowing those facts, let's get back to our journey and revisit stations in order to try to identify where things could go wrong. While visiting the input, it is possible that it wasn't defined that the glue should be stable in the human body temperature, 37 Celsius degree. As for the output, it may be defined as an input that the glue should be stable in 37 Celsius degree. However, the chosen glue wasn't stable in all body temperature range, which may be higher than 37 degrees. Jumping into verification station, in case that according to the supplier statement, the chosen glue is suitable for all temperature range, but verification wasn't performed in order to verify that bonding quality will be kept during using the pacemaker materials. Next station may be the validation, which conduct but haven't taken into consideration the aging of material, including the glue, during the product shelf life. Last stop is the design change station. Here, it might be that the epoxy supplier notified about a change in one of the glue material. This change may affect the mixing time of the glue, but there's no verification was performed for this change before implementation in the production. Remember, missing information or mistake in each one of the steps may lead to severe results. Therefore, next time that you will have a new product development, in order to avoid the next recall, verify you follow the roadmap. Be accurate in defining the user needs and inputs. Perform validation and verification as required, and manage change properly. All of those together will minimize the risk for the patient and for your business. And remember that quality and innovation are in your hands. Thank you.
Wow, and that's a wrap, folks. We finished our third and last day. Our conference is finally over, and we couldn't be more thrilled you were here with us. Thanks again to all of our amazing sponsors. We truly couldn't have done this without you. Your companies are true allies, helping us to support diversity and being part of the change where women will make 50% of tech speakers worldwide. Thanks to all of the people who were involved in making it happen, helping us to make my dream come true. To our speakers and keynote speakers, you are truly amazing. We're counting on you to become the next thought leaders of the tech industry. Thanks to Event Handler for producing the conference, and obviously to all of our course mentors and world-class instructors turning the academic course from dream into reality. Be sure to follow us on social media, invite our speakers to speak at your next event, register as a speaker on our platform yourself, or register to our next round of the Speakers Academy. My name is Moran Weber, and on behalf of me and Women on Stage, we really thank you for being here with us, and we hope to see you again at our next conference.